Hello everybody, this is Namanjan and welcome back to this series of tutorials where you're going to learn how to make a role-playing game using Unity. So last time we learned how to make a partial combat system where our player goes in near an enemy and we can select the enemy by hovering over it and press spacebar to reduce their health. As you can see over here, this guy has a health of -20, and later on we're gonna make it more complex and better by adding more features like adding enemy AI and making the enemy more active than it was before. So let's get started. So before we actually start making the enemy the opponent of the player, we're gonna learn inheritance. Now, inheritance is basically what it sounds like. It is basically inheriting features from another class. So you have different classes over here. For example, you have a player class, and then you have enemy and click to move. And one class can inherit features from another class. So let me give you an example. Let's go to a player. And for example, let's say we have a dog class. Oops. So let's say we have an animal class. And what we can do is animal can have different variables. So for example, it has a name, it has number of legs, and and other variables, blah blah blah. So now what we can do is we can make another class called dog. We can name another class called cat, and these two can inherit animals. So it inherits all the features of animals. And when it inherits the features of animals, it inherits the variables. For example, it inherits the name and number of legs and so on. And then this can have other methods like make sound method and walk method. And the dog and cat will automatically get these features, so you don't need to code them again and again. Now you already do inheritance, but you probably don't know you're doing inheritance. For example, over here when you type in semicolon mono behavior, that is inheritance, because you know how we execute update and start, and they are automatically called every frame, and start is automatically called when the game starts. That is because we are inheriting from mono behavior. If we were not to inherit from mono behavior, we would not be able to actually execute the code here. So let me give an example. Let me just make a random class, and let me call it random class. And we're gonna attach it to the player. So we're gonna attach random class to player. We're gonna go over there, and in the update method, we're gonna debug.log, and then we're just gonna say this is the random class. So now what you'd expect is that it would actually whoops. Let's call it random v. 1 second, I think it's to do with the name. Okay, there we go. Just call it anything random. This is random. Let's go. Okay, and then you're gonna play. And as you can see, it prints out this is random every frame. But now if we go back and actually remove this mono behavior and play again, we will actually not generate any code because it's not inheriting the features from the mono behavior. So that is basically inheritance. And so why am I teaching you inheritance? Is because player and enemy are they have similar features that can be inherited from a base class. So what I mean is that once we go into player, we have very similar variables. For example, we have a variable name, health, and damage, and here we have a variable name, health, and damage, and we will eventually need a variable public float range to describe its range and how much it can attack. So we basically are duplicating variables over here, which is extra code that we don't need to write. So we can inherit all these variables from a base class. So we're gonna make a base class now. Oops. And we're gonna call it creature. Okay, that is not the best name you can give it because I cannot think of any name, but we're gonna call it creature because our enemy is gonna be some sort of creature and we humans are creatures anyways. Okay, so let's go ahead. And this, as normal, whoops, creature. This is going to extend mono behavior. And now what we're going to do is we're going to delete all these methods for now. And we're going to make the variable names that we were talking about over here. I'm going to call them public string name, public int health, public int damage, and public float range. Okay, and now what we're going to do is we're going to go to our enemy. We're going to delete all these variables, and we're going to extend creature instead. And now you'll know. Now you might say that okay, now we're extending creature, but we're not extending mono behavior anymore. But what's happening over here is we're extending creature, and we inherit all the features of creature. And creature also inherits mono behavior, and it inherits the features of mono behavior. So that means that enemy also inherits the features of mono behavior. So we're gonna do this. We're gonna do the exact same thing with our player. So name, health, damage, range. Name, health, damage, range. Okay, and we're just gonna delete all these. See, we already have so much less code, and we're gonna inherit creature. And now if we go back over here, we deleted the script, we don't need this anymore. And now you'll see that our player still retains the same variable names since we inherit them, and our enemy also has the same variable's name. So now what we did is we took two places where the code was the same, and we kind of factorized it into one class over here, so we're not duplicating code anymore. So now what we're gonna do is in our enemy, we have our get hit method, and we need the same method for player because the enemy is also going to hit our player. So we're gonna go over here and we're gonna make a public void get hit. But now you're gonna be like, wait a minute, we already have a get hit method over here. Why don't we just copy and paste it in our creature class over here, just like that? And now we can delete it from here, and we don't even need to write our code over here. So our code is even shorter now. We are just inheriting features now. So we can also inherit methods. So now let's go ahead and create an attack method for our enemy. Now we cannot really inherit our attack class because we cannot have the same common method for our attack method since they're going to be different implementations. But what you can do is you can go over here and you can type in protected. Now what protected means is, so there are three kind of variables you can have: private, protected, and public. Private is basically variables that can only be visible within the class. So for example, what I mean by this is if you go to the player class and you have void attack, by default C# sets all your variables and methods private. So you cannot access it from other classes. So if you have a player over here and you do player dot get hit, see, as you can see over here, you can actually access get hit. But if you say player dot attack, you cannot actually access the method because it's private. And now protected is basically variables that can be seen by your child classes. And child classes are the classes that are inheriting the features. For example, enemy is a child class of creature since it's inheriting creature. So here, whenever you type in protected, it can only be seen by your child classes and no other classes. And public is basically visible everywhere, so it's like publicly available to every class. So now, what we can do is, since our implementation of our attack method is different in our enemy and player, but they're named the same, and a creature needs an attack method, we can have a protected ward attack. And we're gonna make this abstract. And once we make a method abstract, we are supposed to make the class abstract. And now I'll explain what abstract is. An abstract is basically, if you have an abstract class, that means that that class is not instantiatable. You cannot create the class. So basically, you cannot make a copy of this class. But what you can do is, you can inherit this class and make copies of those class. Now that might sound a little bit confusing, but just hold it right there for now. So once you have an abstract ward attack, what happens is you don't need to define the method. For example, you don't need to actually say what the method does. You can just leave it empty and it's very important to put the semicolon at the end. So you can just say, okay, I have this method, and I promise that the child classes that inherits my method, that inherit me, is going to define what this attack method is going to do. And now, since this is a child method, this is a child class, we're forced to override this attack method. And you have to go to our player and protected override. Now, why we do this? It is basically a way of making sure that all the creatures have an attack method. So now that we have this, we're just gonna check if we have errors by any chance. And we do not have any errors. So if you just basically go back to your enemy, suppose, and you do not define an attack method in our enemy, this will hopefully give an error saying, enemy does not implement inherited abstract member. That means that since this inherits creature, we have to implement this method, and we're going to implement this method. And we're going to call this method. And we're just going to say if player, since we have a player over here, we made a variable over here, player. If player dot, or we're going to say vector 3 dot distance, we can say player with big P. Remember to put in big P, because the difference is once we have a big P, we're actually accessing the script without using this. Okay, let me take this out actually. Just remove the variable for now. So we're gonna have a big P player dot what was it? Opponent. Or actually, I'm just changing my mind. Sorry about that. Let's have a player variable over here. We're gonna say player with small p. So we're accessing the player variable, player dot transform dot position and transform dot position. Oops. Okay. So now what we're doing is we're checking the distance between the player and our position. And we have to check if it is less than the range. And remember, we already inherited range. So when we say range, we're actually referring this variable over here. So if it is less than range, I'm going to debug.log attack. Okay, there we go. We're going to go ahead, play, and then we're just going to get some errors. Oh yeah, So what the problem is, we have our player over here, but it is null. It's nothing. We need to set it to something. So we're gonna make the small variable over here called public static player. Now this might look very stupid at first because we are having a player variable inside the player. Now the reason we're doing this is, first of all, in our awake method, we're gonna change this to awake, and now I'll tell you what the difference between awake and start is. So we're gonna have awake and starts. So what is going to happen is, awake is always called before start. So if you say debug.log awake, oops, and you're gonna have a debug.log starts, and we're just gonna remove this for a second. Now what you're gonna see is awake is actually gonna be written before start, and that is always going to happen. That is guaranteed to happen. So if you play, as you'll see, awake comes before start. So what we can use this to our advantage, what we can do is, in our start, we can say player is equal to this. So what this is saying is, set this player to myself so that other scripts can access me. So now what we can do is, in our enemy, we can say player is equal to player.player. Now this sounds really stupid. So what's happening is, we're setting this variable over here, which is player, or let's call this opponent to make it easier. Opponent. So the opponent of the enemy is equal to player.player, and player.player is this static variable over here. It is the same way we are accessing the opponent variable over here. So we are saying big P player with the big P dot opponent is basically accessing this variable, and big P player dot player is accessing this variable, and we set this variable to this class. So now we can actually access this class, and make sure to set this static. So now we're going to say opponent, and oops, we're going to say, and we're going to just name this back to player since I've told you what that means. And we're going to play. And our ranges for enemies actually it's 0, so it will never print that. So we're going to make it 3. And once we go in, you'll see that the moment we're in range, it prints out attack because it is within range. So now what we can do is, we can actually, since a player inherits creature, we're going to actually, we're going to make this protected actually. Since it inherits the creature, we know that the player actually has a get hit method. So we're going to go to our enemy, and we're going to say player.getHit, and we're going to send in our damage, since we inherit the damage variable. So we're just going to check, and then now we're going to play. We're going to check our player's health, which is 100. Now we're going to go close. And you're going to notice that our health actually decreases really quickly over here, as you can see. Now that's because it's decreasing our health every frame. If you'll notice over here, it is called every frame, and we're decreasing our health every frame. So we need a way to control the attack speed of our enemy. So now that leads us having a new variable called attack speed. Now in the future, our player is also going to have attack speed, because we know that a player is going to have attack speed. So why not just go into our creature class and have a public float attack speed. And we're going to make a comment with / saying that attack speed is described 1 attack per second. So it's just commenting on how the variable is described. So if you say 2 seconds, 2 float, so F to describe it's a float. So we're going to attack once every 2 seconds, or once every 2.5 seconds. So that is how we're going to control our speed. So now we're going to use this technique, which I like to call a block technique. I'm not sure if it is a thing, but it really works nice for me. So what we're going to do is we're going to say, okay, now the player is attacked, and now we have to wait for 2.5 seconds. So in those 2.5 seconds, if we try to attack again, we're going to block the attack because we're not allowed to attack for the next 2.5 seconds or 2 seconds. So the way we're going to do this is we're going to make a bool, and it's going to be private by default. So bool block. Now bool is a variable that can have two types. It can be either true or false. So it's for logical stuff. For example, you can say you can use this in if statement. So if block, and then you can do stuff. So that is basically for conditional statements and stuff. So now what we're gonna do is we're gonna use a word called invoke, and we're gonna make a new method called block, or we're gonna actually call it unblock. And in this unblock, we're gonna say block is equal to false. Now I'm just gonna explain what I'm trying to do over here. Or sorry, block is equal to true. Or false actually, because we're gonna unblock. Yeah, okay, that works. So what we're gonna do is we're gonna first, when the player comes in range, we're gonna attack. So we're gonna say player.getHit, and then we're gonna hit the player as usual. And what we're gonna do is we're gonna set block is equal to true, because now once we hit the player, we want to block the attack. We cannot attack the player for the next 2 seconds, so we're gonna block it. But once we block it, we need to unblock it after 2 seconds, and hence we have to call unblock after 2.5 or whatever seconds we have over here. So we're gonna invoke unblock, and we have to put these in quotation marks, double quotation marks. We're gonna call unblock. Make sure the name is the same as here, and we're gonna call it in this much time, so in 2 seconds, and that is attack speed. And now one last thing is we need to do is we need to go over here and put a double and over here, this double and sign over here, and we have to say if only if you're not blocked. So what this means is only if you're this exclamation mark is the same as not, so it flips the bool. So if the block was true, it flips it to false, and if it was false, it flips it to true. So it's basically a not. So here we're saying if you're not blocked, only then we can execute the statement. And once we come over here, we're gonna block it, and then we're gonna unblock it after 2.5 seconds. So when block is true over here, it will not get into the statement, because what this here means is that to execute code in this statement, this line over here, this big line, and this line has to be true. Both of them have to be true to get inside the statement. So it is basically the same thing as writing 2 nested statements, if not block. I'll just write this so it's easier to understand. So if not blocked, we're going to do this stuff, and hopefully it's going to work without any errors. So 2 seconds was the attack speed is 2 seconds. We're going to go over here, and you're going to see our player is actually losing health every 2 seconds. You're going to see over here 60, 50, and that's how you can set attack speed. Now we need to make the enemies more movable. Now they're standing and basically doing nothing. So we're gonna make the enemies actually follow the player. For now, we're just gonna deactivate 2 of the enemies just to make it a lot simpler for us. So we're gonna use the same logic as we use for the player. So we're gonna create a nav mesh agent for this guy over here. So we're going to add component. We're going to add a nav mesh agent right there. And we're just going to set its radius a little bit bigger. Yep. And if you remember, nav mesh agent basically helps you move around the terrain. I'm not going to explain it again since I've already done it. And we're going to have nav mesh agent nav agent. There we go. And then we're going to say nav agent is equal to get component. And then we're going to say nav mesh. Oops. I'm just going to copy this nav mesh agent. And we can also actually put this nav mesh agent in the creature class, since both the player over here, oops, oh, that's click to move, never mind, actually just ignore the last thing I said. We're gonna put it back over here. Yeah, the thing is, I thought that the player actually had the nav mesh agent, but it's actually the click to move script, so we cannot actually inherit from here because the player does not have the nav mesh agent. Okay, so now what we're gonna do is we're just going to make a new method called void follow player, and we're gonna say nav agent dot set destination, and we want to set the destination to the player's position, so we're gonna say player dot transform dot position. So this is basically simple stuff we did before, and in our update we're gonna follow player. And this shouldn't be very complicated. And as you can see, simply by simple, I think it's just 3 lines of code, our enemy is following our player. Now you can adjust the speed as you want, and you can go over here and add nav mesh agents all you want. No problem. Oops, that was meant to be 0.7. But there is going to be one problem. You're going to see that they don't have local avoidance, and they're pushing me aside, which is kind of annoying because you can see they're like pushing me inside. So the way you can fix this is you can go to your nav mesh agent, and you can go to your avoidance priority and increase it more than the enemy. So our enemy avoidance priority is 50, and we can make our avoidance priority 75 for our player. Oh, actually not, I mean lower it, whoops, to 25, so they have to be lower than the enemy. And once they're lower, you're going to see that they actually don't push you around. There you go. So you're basically in one place and they cannot push you, but you can push them around, as you can see over there. Okay, so now that we have created very basic AI for your enemy to follow you, you want to create a little bit more complicated AI. For example, if your player is miles away, you don't want the enemy to still be chasing you. As you can see, they're still chasing you. So we need to set a minimum distance for them to chase you. So what we're going to do is we're going to create a method over here, and we're going to call it void range, and it's going to have and what this method is going to do is it is going to check the range between you, the enemy, and the player, and it's gonna take in float range. And what it's gonna do is it's gonna do what I said. So it's gonna take a vector 3, and also, sorry, I'm just all over the place right now. It's gonna return a bool. Now this is something new. So when we say a bool over here, it means that it has to give back a value. So it has to, return something. So return false. So now the method is pretty boring, and whenever you call this method, it's going to return the value false every single time. So now what we want to do is when you call it, we want to return it true if the enemy and the player are within this range. So you're gonna say if, we're just gonna copy this method over here, this code of line. If the vector 3.distance between the player position and the enemy position, which we are in, the enemy class, is less than the range, we're gonna return true. Else we're gonna return false. There we go. And we are going to make stuff shorter, we're just gonna go over here, replace this line with range, and pass it the range variable. So now what we're doing is we're calling the range, or we're gonna call it is in range to make it a little less confusing. Is in range. So it's gonna check if returns true if the player is in range with the enemy in the given range. Oops. Okay, so we're gonna say if is in range within the attacking range, which is over here. And we're gonna make a new variable called public float chasing range. So this, if the player isn't within the chasing range, the enemy is going to start chasing the player. Yeah. So in follow play, we're going to say if is in the chasing range. So now you can see how higher level language can actually make a lot of sense to us. So it just simply flows. So here you can see if is in range of the chasing range, nav agent.set destination player.transform.position. So now you can see how it flows like a language. You can actually read out the language and understand what it does. And that is why good naming is very important. Now we're going to go over here, and in our enemies, we're going to see chasing range over here. So we're going to set it to 10. Oops, that's 19. 10. And 10. And we're going to play. And as you can see, they're currently not chasing. And if I go to my player and bring them a little closer, how close do I want them to be? Oh, you can see that they actually start chasing. Maybe I want it to be 20, the chasing range. Let's make it 20. And then if I go to the scene and if I bring them closer, you'll see that they start chasing only when I'm in a range. And if I go too far away, they stop. They're going to go to the last position and they're going to stop chasing. As you can see, they go and they stop chasing. They go to the last position they've seen me. As you can see over there. Now that might be a little stupid, since what is happening is that it sees me. For example, I'm going to bring it over here. It sees me in the last position and sets the destination to that position. So maybe if we go out of range, we want to set the destination to nothing. So we want to reset the destination once the player is out of the chasing range. So here we can add a simple else and say that nav agent.set destination to transform.position. So what's happening is that if the player is not within range, we just set the destination to our current destination, which means basically nothing because it's not going to move, since it's setting the destination to itself, which is very trivial, but it's just necessary so that it does not simply follow unnecessarily. So you see, as the moment it goes out, they instantly stop, as you can see over there. So that is it for today. A little bit of enemy AI and basic combat system. So now the game is a little bit more interactive. So next time we're actually going to get into graphics and add some graphics to make it look a little bit more cooler. And we're gonna do some code cleaning since it looks like a mess over here, and you don't want your code to look like mess, since it's gonna be very difficult to handle. And you can see our code basically explodes, and we can have so much more code. So if you have liked the tutorial, please like, comment, and share, and subscribe. It really helps. And share this video with any of your friends you might think might help, and it makes everybody happier in the world. So thank you very much, and see you guys later.